Okay, we have a conditional statement here that we're going to try to turn into a proof. This is number 8 on your theorem sheet. So if you want to follow along, you could also grab another sheet of paper or wherever you've been writing your proofs and do your proof on a separate sheet of paper. But I'm going to start by turning this into trying to figure out what the setup is. So the hypothesis of my conditional statement is giving me my given information for what I'm going to prove. Let's start by drawing a picture, because this one's kind of a mouthful if you read it. So if two angles are both complementary to the same third angle, when I read that, I'm getting that we've got a pair of complementary angles. We all know what complementary angles look like. I like to draw them like this. They don't have to be adjacent, but I'm going to draw mine as adjacent angles. And then I also have, I know it said third angle here, so I went ahead and did 1 and 3. Now I've got another angle, and I'll just call this angle 2. That's also complementary to angle 3. So if we go back to that statement, two angles are both complementary to the same third angle. And if I write that as, if I try to list out my given information, we've got angle 1 and angle 3 are complementary. And then I also have angle 2 and angle 3 are complementary. What are we trying to prove here? Okay, well, let's think about it. 1 and 3 are complementary. Complementary means adds up to 90 degrees. 2 and 3 are complementary, so 2 plus 3 equals 90 degrees. So what's the unwritten thing that we haven't said yet that has to be true here about any of your angles? We've got 3 angles. Can we say something maybe about 2 of them? Take a minute and see if you can figure out what would be true. If you're struggling, put some numbers in. Okay, just try throwing a number in there for angle 1 and then see what happens. Hopefully you came up with something like angle 1 has to be congruent to angle 2, because both of those make the third angle, when added to the third angle, make the sum 90 degrees. So that is going to be what I'm going to prove. We're going to call this one, this theorem, I call this the congruent complements theorem. I'll do THM for short. And this is one that's a generally accepted name. I know that different textbooks can have different names, but a lot of people agree on the congruent complements theorem. Number will vary, but in your textbook it is theorem 2.7, just to give you a reference point if you want to go and read it in there. Okay. One other way that this could look, if the picture there is confusing you, try drawing it this way. Just give yourself an angle 1 and an angle 3 that aren't adjacent to each other, and then give yourself some other angle 2 over here, and we've got the same thing going on. Okay, I did say that we would revisit this second part here. Let's try a different color. There's really 2 possibilities for setup for this proof, 2 cases, I should say. You could have 2 angles that are complementary to congruent angles rather than the same third angle. So instead of this being the same, where you've got angle 3 and angle 3, we could have actually 1 and 3, 2, and let's add another angle here, call that 4. And we could know that, in this case, we could know that angle 2 and angle 4 are complementary. And as long as we knew that angle 3 was congruent to angle 4, that would have to be an additional piece of given information. Then we could still prove that angle 1 and angle 2 are congruent, just as we've set out to do in this case. So we would have to know this, and then we could go ahead and try to prove that angle 2 and angle 1 are equal. So you're going to pick one of those to do. I'm going to go ahead with my first way of doing it, but either one, you don't have to do both cases, just pick one. Okay, I'm going to go to the next page, and I'm going to set up my proof. Actually, I'm going to see if I can shrink this down so we can still see it, but we can continue on with our proof. Whoops. Come on. No, I guess that's as small as it'll let me go. Okay, so setting up my proof from here. So I've got statements on the left and reasons on the right, and of course I'm starting with my given information. Given information was angle 1 and angle 3 are complementary. And then angle 2 and angle 3 are complementary. If you're struggling with what to do next in your proof, I always tell you to look at your given information and do something with it. If you can make an equation, that's great. Look for keywords. So the word that I'm seeing is I'm seeing complementary twice, and I'm going to see how can I use my complement, what complementary means. Specifically, I'm going to look to my definition of complementary and see if that gives me any idea of what I can say. Definition of complementary: two angles that sum to. Angles are complementary if and only if they add to, their sum is 90 degrees, they add to 90 degrees. So I'm going to make an equation that says that. And my equation is going to be measure of angle 1 plus the measure of angle 3 equals 90 degrees. And if I can do that for angle 1 and angle 3, then I better be able to do it for 2 and 3. Add to 90 degrees. Okay, so from here, I need to somehow, I'm trying to get to remember what we've got in red up here. I'm trying to get to angle 1 and angle 2 are congruent. I know it's small, but that's my goal, is try to prove angle 1 and angle 2 congruent. So we're going to look and see if there's anything else I know. And I know my picture's kind of small, but we don't have supplementary there. We can't add them up to 180. We don't know that anything's equal. So I'm going to go ahead and see if I can move on to the next phase of my proof of, I've got my information stated. Let's see if I can move on to the algebra part, put things together. So I'm noticing that we've got a common 90 degrees right here. So I'm going to use a property, and I'm going to see if you can figure out what property I'm using. I'm going to say measure of angle 1 plus measure of angle 3 is equal to the measure of angle 2 plus the measure of angle 3. So first of all, do you agree? And if you agree, what property did I use? That's equal to 90. That's equal to 90. So therefore, these quantities must be equal to each other since they're both equal to 90 degrees. You should be saying either the transitive or the substitution property for that one. That's a big step there. If you don't get that one, you're going to be stuck for a while. But as soon as you get that one, things should start to fall into place. Because if you're staring at that equation and thinking, okay, I need to simplify things here, you should be seeing something that you can do to both sides. So again, thinking properties. And hopefully you're seeing something common there, a measure of angle 3 and measure of angle 3. So I'm going to try to get to measure of angle 1 equals measure of angle 2. And what property did I just use? You got it. ESPO or subtraction property, if you like to write that out, that's fine. I left kind of a blank there, and I'm going to actually make this step 5. And I'm going to throw in here a step that we may or may not have done before. It's kind of one of those like optional steps, but if we're being 100% clear, remember, you're trying to convince somebody when you're writing a proof that you're absolutely 100% sure this is true. I'm going to throw in here that the measure of angle 3 equals the measure of angle 3, and you're probably saying, duh, I know that. But if I'm going to subtract it, I really want to make my reader aware of the fact that, yes, I'm subtracting equal things from both sides. And unlike numbers, we don't know what the measure of angle 3 is. If we're subtracting 5 from both sides, okay, then we can agree 5 is equal to 5. So we're going to use our reflexive property, is what you should be recognizing in that statement that I just made, just to specify that. Not a huge deal if you forget that one, but just something that I wanted you to see. Really close. We wanted to prove angle 1 is congruent to angle 2, and I'm almost there. I haven't done it yet, though. Don't get tripped up and forget this last one. I said the measures are equal. I want to say they're congruent. So angle 1 is congruent to angle 2, and I just went from saying if their measures are equal, or sorry, if the angles are, if their measures are equal, then I know the angles are congruent because my definition of congruent angles Whoops. Oh, I didn't want to erase the whole thing. Okay, let's try that again. Angle 1 is congruent to angle 2. Sorry, hit the wrong button. And my reason is going to be because the definition of congruent angles tells me if angles are congruent, their measures are equal. If measures of angles are equal, then they are congruent to each other. And that's a really good proof of what we call our congruent complements theorem. I want you to take that and I want you to model the same idea for the next one, number 9 on your page, which we're going to call the congruent supplements theorem. The only difference is that in the congruent supplements theorem, you're going to have a picture that looks more like this. One of two things. You're either going to have angle 1 and angle 2 are supplementary, or we'll go with, let's keep with what we did here before. Angle 1 and angle 3 are supplementary. And then you could say angle 2 and angle 3 are also supplementary. And try to prove angle 1 is congruent to angle 2. That's option A. Option B would be, let's see if we can challenge ourselves to do the other proof. Remember I said there's two cases here. Angle 1 and angle 3 are supplementary. Angle 2 and angle 4 are supplementary. And we also know that angle 3 is congruent to angle 4. Can we now prove that angle 1 is congruent to angle 2? You're going to have to write out your given information. And then here's your proof statement. I wrote that one out for you. But you are going to have to write out your given information. Okay, that should help you with number 9 and kind of follow the same reasoning process that we did for number 8, and you should be just fine with that.